Okay, this is then the Year 7 Forces knowledge test, right? And it's pretty much all the answers that you need, right, to be able to completely nail the end of unit knowledge test in forces. Right. What is a force, a contact force, and a non-contact force? So a force is a push, a pull, or a twist, right? So they're then the three things that a force can ever be. The contact force is a force where the forces are touching, and an example could be friction. A non-contact force is where forces are not touching. Okay, and a good example of that could be magnetic. You know where magnets don't actually touch? Right, add in the forces. There's a person walking, right? So that one there is up thrust. Okay, so that's the force that's coming up from the ground. The forward one is then thrust. It's kind of the force that's making them go forwards. We've got air resistance, or it could be drag. And then what we've got here is we've then got gravity, which is often put down as weight. Explain how to calculate the resultant force. So what you've got here is you've got a resultant force. So there's your object, and resultant means work out an answer. And what you've got to do is you've got to look at all the individual ones, right, and see what's happening. So the force up is 2 newtons. The force down is 2 newtons. So what they do is they counteract each other. Then what you do is you look at the forces left and right. You've got 4 newtons going to the left, and you've got 8 newtons going to the right. So therefore you go 8 newtons, take away 4 newtons equals 4 newtons. And because the bigger force is going in that direction, and you can also tell that from the arrow, because the bigger force is going in that direction, the answer is 4 newtons right. But what you've then got to do is you've got to try and explain that in your own words when you're actually doing the test. Question number 5, right? Complete the table. Weight, what is it, and how are they different? So weight is the effect of gravity, okay, and it's a force, and that is measured in newtons. Mass it's a measure of matter, okay, it's kind of like the particles, right? And what it does is it stays the same everywhere, and it's measured in kilograms. Okay, I always like to do this. Here's a picture of me, right? There's me. Okay, if I am 100 kilograms, right, and I go to the moon, because it's my mass, right, my matter stays exactly the same. My mass on the moon is 100 kilograms. Right? It doesn't change. Go to the sun, go to anywhere, it doesn't change. If my weight was 1,000 newtons, right, that is due to gravity, and I go to the moon, my weight will be less because the force of gravity on the moon is less. If I go to Saturn, it will be more because the force of gravity on Saturn is bigger. So mass stays the same, weight changes depending on the gravity. Question number 6. Complete the flow diagram based on Newton's first laws of motion. All right, so an object can be, if the forces are balanced, it can be stationary. Right, so what we're doing is you're talking about an object here, right, and an object, if the forces are balanced, it can be stationary. If the object is moving, right, then it's obviously travelling at a certain speed, but the forces are balanced, then it will then be going at a constant velocity. And if the forces are then unbalanced, it will change velocity, which then means it will either accelerate, or decelerate, depending on the forces. So this is then Newton's first law of motion. So he says that if an object is stationary, the forces are balanced. If the object are moving, it could be doing 2 things, right? If the forces are balanced on that moving object, it will stay at a constant velocity. It will just keep going at the same speed. If the forces are unbalanced, right, so then there's forces working on them in different directions, it could be, God, my writing is terrible in that, right, it could be accelerating, right, if kind of like the force behind it is bigger, or it could be decelerating, right, which then might be slowing it down. Right, what is terminal velocity, and describe the 5 stages, right? So terminal velocity is the maximum speed or velocity an object can reach. Okay, so if you think about it now, right, what happens? A dude on an aeroplane jumps out, right, and what he's going to do, he's going to keep on accelerating until he reaches the maximum speed that he can then reach. So what I'm going to do is I'm just going to do this in very little kind of brief bullet points. What happens? He jumps out, and what you can do, then you can look at any diagrams that you're given. The weight makes him accelerate down. Okay, so there's the weight arrow. Okay, so the weight is then making him accelerate down. Right, that is stage 1. Stage 2, the weight stays the same, but now what you've got is you've got air resistance increases. Okay, so there's the air resistance. Eventually, what will happen is weight will equal air resistance. Okay, so now we've got that. That is then terminal velocity. It's where the weight and the air resistance are exactly the same. Right, and if you wanted to be daft and put his arms in, right, then what it'd do is it'd then start accelerating until he reached another terminal velocity. Then, what he does, he opens his parachute. And all of a sudden, there is a massive air resistance increase. So now the arrow is huge there like that. Okay, and so what he then does is he then slows down. What colour shall I do? I'll do that colour. He then slows down until he reaches his second terminal velocity when the weight and the air resistance are then equal to each other. Question number 8, draw and label the magnetic field around the bar magnet. Alright, so what you've always got to remember is you've always got to remember that they go from north to south. And that's supposed to be arrows, arrows, arrows. Always go from north to south. Okay, always go around there like that, north to south, and then these ones coming out here, right, kind of like little funny little tail things, north to south, so always going away and then always coming in. Okay, so write a method you will use to measure the extension of a spring. Really, it's set up the equipment. Okay. Number 2 is then what you've got to do is you've got to look at where the ruler is at that point there. So you've got to pinpoint bottom of the spring on the ruler. Okay. Number 3 is add a mass. Right, so what you do then is you add a mass onto the spring here itself. And number 4 is you do end length, take away start length. Okay, so if it then moves down to here, then what your extension is from there to there. Right, keywords. Right, the force of an object moving through the air that causes it to slow down is air resistance. Okay, also called drag. Drag, the force acting on an object, exactly the same thing. The force that resists movement because of contact between surfaces is friction. So when you're rubbing your hands together, right, that is friction. The law that states if you double the force of an object, the extension will double. That's all about the spring that we just talked about. A piece of equipment used to measure the weight in newtons is a Newton meter. Right, so now what I've done is I've just gone through all the basic facts to do with the forces topic. Right, they're the answers to the tests that you're going to get at the end of the unit. Right, but what you also need to do, you need to look back at your school notes, right, and you need to revise the work you've done in school, because you're also going to end up having the GCSE style questions as well. Right, but again, watch this video, fill it in, repeat, repeat, repeat. So I'm just going to write down the word repeat, right, because you need to keep on repeating all the time to remember things.